All right, today we're going to take a look at section 7.1. This is our introduction to finite decimals. And as with any section of material, when we start it, we start with vocabs and things to make sure we're all on the same page when we're talking about it. So to start with the word decimal, the word decimal comes from the Latin word meaning 10. So this prefix, DEC, hang on, get a pen that's the right color so this will show up. The DEC is 10. All right, so you're seeing the word 10 in there. And we need to actually talk about the location, or not the locations, but the names of the locations in a number. So we're going to start by making ourselves some places. There's 2 before our decimal point, and then I'm going to draw a few afterwards. How many? 6. Okay. Each of these place values has a name. So we'll start from the far left and move to the right. So this is the tens place, and this is the ones place, or it could be called the units place. So tens and ones. We have the decimal point, and then on the other side, we go to the tenths place. You get that THS on the end, tenths. And then we have the hundredths. And the thousandths. Now, for most of the purposes of working with numbers in everyday life, we can stop at about the hundredths or the thousandths place. We don't usually get a lot more than that. However, in some science topics, we will. There will be reasons to do so. So I'm going to just go through a few more of them so that you're aware, and aware of the structure, because the structure will repeat. So after we have thousandths, we have 10 thousandths. And then we would have 100 thousandths. And then we would have millionths. If we had one more, what would the next one be? 10 millionths, and then 100 millionths. Do you know what comes next? Billionths, right? So it's the same things that we would do on the other side of the decimal point with that THS on the end. That's what's going on. Okay, so the first thing we're going to actually do is we're going to take a number and we're going to write it in words. So if we only had 2 decimal places, what we're actually seeing is the way you're supposed to write your checks if you ever write a check. Okay? I don't write checks very often, but I write them occasionally. I pay my tithe by check. That's one that I do. So there are going to be opportunities in your life where check's really going to actually be what makes the most sense. Maybe it's not the only option, but it might make the most sense. So if you haven't had an opportunity to work with a checkbook before, this is going along with that idea. So the 3 and the 2 beforehand, you know how to say that from the time you're little bitty. How do you say 3-2 at the beginning? That's 32. Okay, so we're going to start with that. So we have 32. So that's fine. The decimal point is read as the word, do you know? And. So I used to get in trouble in 2nd grade because I put and in the middle of my words when there's not a decimal point, because we didn't do decimal points in 2nd grade, right? You haven't gotten to that yet? So you'd see a number like this, and I would say 760. My teacher would get all kinds of upset because I put the word and in there, okay? Because that's not how you're supposed to say that. And actually means the decimal point, okay? So we got our and. The next thing that we do is we read this number all together and ignore where it's located. So just 4236. So if you just saw the number 4236 all by itself, what would you say? Good job, without the word and. Some of you still put the word in, just like I do. Okay, so you would say 4,236, right? That's what we're going to write down next. So start with that. So we're going to say 4,000. $236. Okay. Obviously, we can't leave it quite like that because that looks like another value that would be bigger than 1, right? It'd be on the other side of the decimal point. So we have to indicate what place value it ends in. So this location here at the end tells us that, the very last place. So if you take a look back over here, this is 4 decimal places in, right? I've got 4 numbers after the decimal point. So what place value am I in if I'm 4 after the decimal point? 10 thousandths, okay? So this one right here is the place value where my number ends. So I'm going to write that word at the end of my description. 36 10 thousandths. You might be thinking, well, why does it matter? Obviously it's 10 thousandths. What else could it be? Well, if we had this same number and we had a 0, for example, before we had our 423, was it 6? That's 4236. We would write this almost exactly the same as the first one that we wrote. But instead of it saying 10 thousandths at the end, it would say 100 thousandths, because that's the value where I'm ending the description. Does that make sense? So that's why we have to specify where it ends, because otherwise there's no discernible way for us to know the difference between these two numbers, and that's how we discern them. Okay, now we've got one that's written in this words, all these words, and we're going to write it in the numerical value. And I think a good place to start is with the word and, because the and is your decimal point that we talked about before. So 536, what does that look like? 536, yeah, just saying it in individual numbers is what we're looking for, so good job. 536. Then we have our decimal point. So let's figure out what place value I'm in. The very end of it tells me where I'm in. I'm in the thousandths place. How many place values in is that? Like, how many do we need to go?
3.
I need 3. So if I just mark these 3, I'll be making sure to put a number in each of those places so I don't get tripped up on where the numbers go. The value before that is before the word thousands but after the word and, is 76. So what number will go in the first place after the decimal point right here?
0.
It'll be a 0 on this one, because the number 76 means the 7 and the 6 have to be beside each other, right? And they have to end in that third place value, which I've marked. So this is how I would write the number, 536 and 76 thousandths. All good? Great. All right. Our base 10 expanded form is how our book shows this. The same place values that we drew before, I'm just not going to write quite as many of them. So we're going to do a decimal point, and we'll do, that's not a very good decimal point, that's better. Just do 3 of them for now, I think is probably sufficient for argument of what we're talking about. When we're working with the numerical form of the words that we wrote on the previous slide, this tens place would be the number 10. The units place or the ones place would be the number 1. Now the value right here is supposed to be the tenths place. And the tenths place means 1/10 in fraction form. That's how we say that word, right? We see this number 1 over 10 and we say 1/10. At least we should. We tend to do this thing where we say 1 over 10 like I just did, right? But this is 1/10. The next place is the hundredths place, right? Hundredths, well that's 1 over 100, right? 100 on bottom. And then the thousandths place would be 1 over 1,000 and so on. Now, there's a note here, and it's really important because it's going to catch you if you're not paying attention to it if you look in the back of the book. Your book likes to use negative exponents here. So, for example, when you see 10 to the negative 2, what it means is it's 1 over 10 squared. We've done the exponent rules back in section 6.3. And then 10 squared is 100. So instead of writing 1 over 100, they would write it as 10 to the negative 2. Okay, that's not wrong. It's absolutely right. But I don't really want to do it that way. And I have a really good reason for it. So generally speaking, I think you should probably do what your textbooks do most of the time, and I do that. But when there's a just cause for going against what a curriculum says, you should, as the teacher, feel comfortable in doing that. And this is one of those places where I feel that way. I think that we lose the intuitiveness of what the place value means if we write it in negative exponents. If I write it as 1 over 100, intuitively you know, if I had 100 of something, like 100 pennies, I know what that means. If you write it as 10 to the negative 2, the meaning gets fuzzy and lost, and you don't have a good idea of what you're talking about anymore. So we're going to leave it in values that look like numbers over 100 or something like that, instead of doing it in negative exponents. But if you look in the back of the book, they're going to use the negative exponents, okay? So what do I mean by that? Well, here's an example. Somebody read the number for me as you should read it. If we were writing it in words, what would this say? 103 and 300. Good. 103 and 300. So everybody's get that? That's how we'd read that. Good, good, good. And the way we're going to write this in expanded form is we're going to write the number 1, and its place value is the hundreds place, plus the number 0 is in the what's place? Tens place. My next value is a 3, and the 3 is in the ones place. Now I have a 0 in the what? Tenths place. So that's 1 over 10 like this. And the last number is a 3 in the hundredths place. This problem works really well to think about money with. That's why I chose the numbers I did. If I write it like that, I could literally go to the bank and get the coins and the dollar bills and the $100 bills or whatever to make this work, right? I need one $100 bill. I need 3 ones, and I need 3 pennies, because that's what 1 100th is. And we can see it in expanded form if we write it that way. That's kind of cool, right? It actually means what we expect it to mean if you're thinking about 103 in terms of money, 103 and 300ths in terms of money. All right, another model that you're going to see used in this section is a decimal square grid. So I'm not going to have a very good picture of it because, I'm drawing it kind of freehand, and you aren't either because you're going to draw it kind of freehand. But you want to draw a large square, and you want to split the large square into 10 columns and 10 rows. So we'll see how well I do today. Well, I'm on a pretty good track so far. Let's see. All right, I definitely have done that in much worse forms before, so I'm pretty pleased with that. If you're doing your homework, right, when you're doing your homework, feel free to use lined paper. I hope you are. For most of you, you're using paper, and so the lined paper will help you keep your lines in order. If you want to, another option is to get grid paper, either because you have graph paper or print off a grid online and then be able to put a sticker and just tape it into your homework for that so you don't have to draw it. You can do it that way. All right, so this is a 10 by 10 grid, and this allows us to talk about how we would model decimals kind of from an area perspective view like we did in section 6.1. So if I take this grid and I want to draw in the number 24 hundredths right here, how many of these little boxes would I need to fill in? 24. And while it is absolutely true that you could fill in any of the 24 boxes you want, you and I are going to both be happier if you fill them in a way that's easy for me to count. Okay? So what does that mean? Well, it means that if you fill in 10 of them, you might as well fill them all in one row, right? And then 10 more makes 20, and then an additional 4. If you pick a random 24 little boxes and start shading them in, I'm going to start being a little bit grumpy. Okay? But this would be 24 hundredths in terms of a decimal square grid. All right. There is a relationship between fractions and decimals, and which fractions turn into really nice decimals and which ones don't. You've probably experienced before when you put in your calculator. Sometimes you put in a fraction and it becomes something that's really easy to see in decimal form, and sometimes it's not. It's either repeating, or maybe it doesn't repeat, it just does this random number expansion that you're not really sure what's going on at the end, and so you don't see the repeat. It would be repeating, but you don't always see it very easily. So there is a real quick way to determine when a fraction is going to turn into a nice or a terminating, or in this section we call it a finite decimal. So if you have a rational number in simplest form, okay, a over b, so it has to be simplified first. It's really important. Underline this. Simplest forms are really important. It can be turned into a terminating decimal if and only if the prime factorization of the denominator contains only 2's and 5's. And if it helps you to say this, this just really means and or. It can have 2's, it can have 5, or it can have 2's and 5's. So for example, if I had the fraction 1/2, the denominator has only 2's and or 5's, it will have a very nice terminating decimal form. It's 0.5. But if I had the number 1/3, it doesn't do that. It has the number 3 in the denominator, which is neither a 2 nor a 5, and it will not have a finite decimal form or a terminating form. In fact, we'll talk more about this in section 7.3. It'll look like that. It's a repeating decimal. It's probably one you're familiar with at least a little bit. Okay? So in order for us to decide if it has a finite form, if it terminates, we need to get it in simplest form, and then we have to factor the denominator. And that's what our next examples are going to do. We're going to take the simplest form, or get it in simplest form, and factor the denominator. So on A, is it in simplest form? No. What will the numerator and the denominator both divide by? 3. So our first step is to divide the top and the bottom by 3. So we're going to divide them both by 3. So what is the numerator if I divide it by 3? Sorry, let me put it here. 3. And what is the denominator if I divide it by 3? 8. And then we're going to factor 8. How will 8 factor? 4 and 2. Now 2 is prime. Doesn't factor down any further, but 4 is not. How will 4 factor? 2 and 2. So I have 3 numbers, and it's the factorization of the simplified fraction denominator, right? 2, 2, 2. And they're all 2's. So is it going to be terminating, ending, right? Or is it going to do something different? It's going to terminate because it's 2's and or 5's. In this case, just 2's. So this one is going to be terminating. So it terminates. The directions say if it does terminate, which this one does, we're going to figure out what the decimal is. You're welcome to check your calculator when you're done with it, but you're going to do it on the paper, and you're going to actually do the division, okay? And you don't have to go back to the 9 out of 24. It's equivalent to 3 out of 8. So by all means, do 3 out of 8. It's going to make it a lot easier. So we're going to divide 3 divided by 8. Now, 8 doesn't go into 3, right? It's too big. So we're going to have to do a decimal, and we're going to have to do a 0. So it's going to look like this. Okay, when we divide with the decimals, we treat them just like we do whole numbers. We think about this like the number 30. So how many times will 8 go into the number 30? 3 times. And the 3 goes above the entire number 30. In this case, that means it goes above the 0. And that decimal that I put in goes straight up to being in front of the 3. So the decimals will line up. Now, 3 times 8 is 24. So the 24 goes underneath my 30. And if I subtract, I get 6. As long as I have a remainder, which I still do down here, I'm not done. I'll keep adding zeros underneath the division sign. I know it's going to end at some point. Why? Because it terminates. I already found that out by the information on the previous slide. 2's are the only thing in the denominator. It has to terminate eventually. So I'm just going to keep going until it does. All right, so I'm going to put the 0 there. I'm going to bring my 0 down. How many times will 8 go into 60? 7 times. 7 goes above my 0. 7 times 8 is 56. And I subtract and I get 4. Still have a remainder. So I put another 0. Bring another 0 down. 40. 8 goes into 40 how many times? 5. And we all breathed a sigh of relief because 5 times 8 is 40, leaving us with a remainder of 0. Now I'm done. All right, the 0 right here tells me I'm done. And it tells me my answer up here is 375 thousandths. That's the corresponding decimal. And like I said, by all means, you should check with your calculator. That's fine. Because if you did make an error, it would flag you and give you some kind of different decimal, and you'd have to go back or be able to go back and you'd be able to fix it, right? Okay, same process for B. We examine, is it in simplest form? No. What will the numerator and the denominator both divide by? 2. Okay, so we're going to divide them both by 2. I have 5 on top, 12 on bottom. What's my next step? Got to factor. So I'm going to factor 12. How will 12 factor? Okay, 6 and 2. 2 is prime. 6 is 3 and 2. So the prime factors are 3, 2, and 2, right? Is this going to terminate? No. Why not? There's a 3, okay? If I have anything but 2s, 5s, or 2s and 5s, I'm done. So I can have 3s, I could have 7s, I could have 11s. If it's in prime form, right, if you still have a 9, let's say you had a 9, you can't make that claim just yet. You'd have to factor the 9 first. Okay, so you got to get it on the primes. But once you do, it's all in primes. The 3 here causes us a problem. This right here tells us that it does not terminate. And the beauty right now in does not terminate is it means you don't have to find the decimal. You're done. That's a faster problem than the last one. Okay? So if it doesn't terminate, the problem ends for us at this point. It won't forever, but it does at this point. Okay. We're going to take a look at comparing decimals. So if we compare or want to put decimals in order, like from least to greatest or greatest to least, we're going to line up the numbers by the decimal point. That means by the place value. We're going to read the numbers from left to right to find the first place where they differ, where they're different than one another. And then we're going to compare the different digits. Is that digit bigger? Is that digit smaller? Well, then the whole number is bigger. The whole number is smaller. Right? And by whole, I mean entire. The entire number of the entire number is, right, one or the other is smaller or bigger. So here's some numbers. And it's really hard when they're written like this in a line to do this. It's much easier if I stack them on top of each other. So that's the first suggestion that I had. Not because you can't do it the other way, but you're probably going to make a mistake if you do it, at least some of the time. So I'm going to stack mine. I'm going to have, and I'm going to write them all out because my handwriting is a little bit bigger than my type screen is. So I've got 13, and then I've got the 4919. I've got my 13, and then I have a 492. Make sure you're lining them up, right, so that your numbers are actually straight, one underneath another. I have 13, and then I have 49183. The last one is 13.49199. Now, it's fine to leave them like this. It is a little bit frustrating that they're not all the same length. So if you want to make them all the same length, you can do that by putting zeros in there. I'm going to go ahead and do that. It's a little easier to look at for them to be all the same length, but if you don't want to, it doesn't hurt anything. And we're going to go one value at a time. So they all match in the tens place. There's all a 1 there. They all match in the units place. They're all 3s. The tenths place are all 4s. And the hundredths place are all 9s. So until I get to the third decimal, nothing is different. But at this point, something is. Third decimal point, something's different. What number is the number that's different? The one with the 2. This number right here is going to be the what number of all these? It's the biggest. So in terms of small, I think it said to order, from least to greatest. So it's the greatest, so it's the 4th number in my values that I'm going to write down in a minute. It's going to be the last one. It's the biggest one. Okay, after I do that one, I'm going to rather ignore it. I'm done with it. I don't need to worry about it anymore. So let's go to another place value. We're going to go to the next one. I've got 9089. The 0 doesn't matter, sorry. 9, 8, and 9. So of the 9, the 8, and 9, which one's different? The 8. What does that mean about the number that has the 8 in it? Smallest, greatest, what is it? It's the smallest, right? It's an 8 compared to the other ones that are the 9. And it is the smallest of everything that remains, which are all smaller than number 4. So this is the smallest number entirely as it is, right? It's the smallest one, so it's going to be the first one on my list. Okay, our next step will be to look at the value at the end. So I should probably just highlight the ones I care about. I care about the first one, and I care about the last one, because the other two in the middle I've already figured. I have 0 on the top, and I have 9 on the bottom. What does it tell you? Which one's smaller? The 0 one on the top. Now, it's not the smallest. I already found that one. That was number 1 here listed. So it's going to be the second smallest. That means this one at the top is number 2, and the one at the bottom is number 3. Yep. And so now I'm going to write them in order. You can write them in order separated by commas or by an inequality like less than symbols will be fine. I tend to use those symbols. So I have 13.4918.3. That's my smallest. So that's the one that I've listed as number 1. The one that's listed as number 2 at the top is 13.4919. I don't need the 0 on the end, so I'm going to leave it off at this point. The third one, the one at the bottom, 13.49199. And then number 4, which is 13.492. Okay, our last piece of information today. Have you heard of the word tithe? Probably all of us have. If you haven't, it's okay. What does the word tithe mean? Like in what context have you heard about it? Church. Okay. Tell me what you know from church about the word tithe. Okay. 10% of what you make. I'm going to write down exactly what Faith said. What you make, you give back. And specifically as it relates to church and or the Bible, you give it back to where? Do you know? To God, but it's through a specific place. Your church, your local church, right? So it doesn't mean you send it to feed the children. Not that that's a bad thing to do, but that's not what we consider tithe. It's tithe to your local church. That's the way that that process is supposed to work. Some people will say sometimes too, like they gave a 5% tithe. You can't do that. The word tithe has a meaning. It means 10%. So you can give 5%, but that's not what tithe means. It really means 10%. Okay, so how is that related to decimals?
Decimals are like in tens.
Which one would relate to our 10% here? Do you know? Close. 0.1, which I think was what you meant, right? This right here. This number as a decimal, this is 10% of a whole number 1, right? 0.1 is 10% of the number 1. So when we think about this number 0.1, what was the base 10 representation we did just a little bit ago? Do you remember how we wrote it? We wrote it as 1 over 10. And how do we read that? 1/10, right? 1/10. That's actually what tithe means. Tithe means a tenth. We turn it into percents all the time. We think of it as 10%, but it really means 1/10, which is the fraction 1 over 10 or the decimal 0.1. We say it something like that too, right? This is the relationship between the word tithe and decimals.